automatically sends you the top 15 bullet points, notes of what happened during those calls. And it's only possible that we're able to do this with the technology that's available today with machine learning. So my angle for today's talk is that I kind of want to give you guys an inside look into how we and how other startups are practically applying deep learning. Kind of taking a step back from the theory, and it's great to learn about like the different layers and the perceptrons in each one, but how would you take that theory and then go and build a company? And so that's going to be the angle for the talk today. Yeah, so this is my background. Back at school, I did a lot of work with unmanned aerial vehicles, drones. We built a drone that automatically gives you tours of campus. You call it over with your phone, it flies over to you, and then you tell it where you want it to go, and then it'll take you there. And then we also, after that, I did a lot of work with reinforcement learning, teaching drones how to herd ground robots, Roombas, those vacuum robots. So there was a competition that's where a lot of my background in machine learning comes from. But I definitely didn't have as much experience as I would like to have had before I started, but I kind of just hopped in. And I'll kind of walk through first more about the company, what we're doing, so you guys can have better context of what it means for us, and then kind of the steps that a common startup should take in order to apply machine learning. So this is my schedule, like every week, and it's back-to-back meetings all the time. I hardly have time to think about what's coming up next, and so my issue was that I would just be too lazy to take notes, and I would kind of drop the ball on lots of meetings. So I built this product for myself, really. And the way it works is our assistant, Fred, joins your meetings just like a participant. You simply invite Fred at Fireflies.ai to your calendar, and then he understands what is important. He looks at the pin, he looks at the dial number, and then he'll join the calendar. And then after the meeting, he'll send everyone a copy of the notes. And our angle on it is, we don't want to give you the full transcript, we don't want to give you 10 pages of notes, but rather, what are those top 15 next steps, actionables, decisions that will really help you continue to follow up. And we're doing this with a deep learning neural network in the middle there that you don't really need to understand too much, but basically, given a lot of sentences, how do you pick out which ones are the most important ones? For us, that kind of looks like ranking each sentence on a scale from 0 to 1. How important is it? And then we take the top 15 to 30 sentences depending on the configuration of the customer. Finally, we email those notes over email, and for the user, the experience is connect your calendar, Fred will automatically find out what to join, and then send you the notes for every meeting. So that's kind of the overview of what we're doing, and now I'll kind of walk through what that takes in practice and the various considerations that you have to think that we thought through when we were designing this. So we kind of think about this in 3 major steps. One is the data collection and processing, which is, I would say, the most important step when you want to go and build deep learning. Ultimately, the performance of your model depends heavily on the data that's underlying, so I don't think enough people spend enough time thinking about the actual data. It turns out that today, in 2018, I was able to do the work of 20 PhD deep learning engineers from 10 years ago by myself with some of the libraries that I'll show you today. So actually picking the model and setting it up, it has learning curve, but it's less impactful compared to the quality of your data. So I'll go through the data collection techniques, how to pick a model, how to actually make it work in production, how to deploy that to your users and make sure that it's performing correctly, and then how I continue to learn over time, this being a fast-moving field. So first up is, how do you get your data? Some companies are really lucky in that the product that they give to their users generates data for them. Other companies have to figure out how to scrape that data from public sources, whether that's like PDFs online or articles that you see. For us, we're lucky because every meeting that happens, users are creating data points for us, which we go in and label based on how important are they to the user, what are you looking at, what are you clicking on, what are you sharing. And this contributes to the model getting smarter over time. And it's not getting, and for us, that's good when you're collecting data from your users because you're not introducing team bias or source bias, but you're actually optimizing your results for the user. One tip for collecting data is you should definitely try to make sure that your product, like the outputs of your product and the data that you produce, align with the predictions that you want to make. If that makes sense. Another big thing is actually storing that data properly. Because you can imagine if you have a huge stream of data, it might be the quickest thing to do is to store it in a CSV file. But spending some time thinking about what kind of database I want to have and what are all the different parameters for each data point that I need can go a long way. So for example, for us, let's say a salesperson has a meeting. We could easily just store the transcript and the individual sentences for that person, but it would help to store this person was in sales, this person is in a large company, this person this was like an intro call, so the first call. And having that level of, or being able to anticipate all the different metrics for your data that can improve the model later can help a lot. So in terms of picking what to store, I always say store everything. Instead of optimizing for one particular result, store as much data as you can and store it in databases if possible. Using automation to do that can save a lot of headache. And I'll show some of the headaches that come up if you don't do this correctly. And then after you have the data, the next challenge is how do you make sure it's labeled properly? So I know Rondon was talking about Mechanical Turk, which a lot of you guys are familiar with, which is where you're able to send all of your data around the world to individuals who will label it for you. That gets expensive, and Amazon Mechanical Turk is actually pretty hard to use. It's kind of outdated. So there's other tools that are better for this, like Crowdflower and Scale-API, if you guys are looking into this kind of technique. Crowdflower is nice because you can give them your data, tell them how you want it labeled, and they'll handle everything else in between. Scale-API is similar to Crowdflower, except it works more like in smaller amounts, so you can send them one at a time and they'll handle everything. In addition to using the tools that are out there to label your data, other things you can look into are how do you build code to label your data for you. So if you know, for example, like just a simple example with a sales use case, that should automatically label as sales. I shouldn't have to send that to Mechanical Turk to do that. And then finally, even if you are getting your data labeled properly, how do you make sure it's the right labels? So you should have a process in place to go back and check. Me personally, I spent a couple all-nighters sitting at my laptop, clicking yes, no, yes, no, yes, no for over 20,000 data points. And after I did that, I was like, never again am I doing this. I would definitely recommend figuring out a good process to label your data because, like I said before, what the model predicts is not magic, it's math. And it depends on the data. So the data labeling comes from the team, what are the biases in the team, what are the biases in the users that are labeling the data, and then those biases will translate directly to your predictions. So definitely spend time thinking about that. So this is another example of what our data pipeline looks like. So for every meeting that happens, we're collecting an agenda, and we're able to understand what is that context that the meeting is in. That context gets fed into the model, which uses it to predict notes for the user. Then additionally, we have a loop where you can tell if the user is happy with the notes, if they're sharing the notes, if they're spending time looking or editing certain notes. And that also goes back into training data. So just thinking about your data loop is important early on and making sure that you're capturing all the pieces of information that could influence your model performance. For us, we only have to train the model once a week with all the new data that had come in, but for different use cases, obviously. And then after you have your data process lined up, the next things to think about, was there a question?
What is an example of the type of data that you collect, and what is an example of some of the labels that you assign to that data?
Yeah, so for us, the core data that we're looking for is given a sentence, what do you do with that? And so we're assigning it a score. Our end prediction is a score from 0 to 1 of how important is this to include in the notes. And so you can either take just a sentence with labels as important, not important, important, not important. That's the base level. But then let's say you have someone who has a client of McDonald's, for example, and they're saying, I will get back to you, or I want to go get McDonald's a slide deck. I want to get McDonald's a slide deck because they're an important client of ours and I need to make sure to follow up on that. Versus someone who's just hungry for lunch. Obviously, so having more precise data, which in this case would be who is your client, are you in sales, like yes, no, those would be examples of how your labeled data can influence your results. So moving on to the model definition. Today, I think a lot of people, I'll take more questions at the end, I'm just going to try to do this, and then today a lot of people want to figure out where do I start with building a model. There's so many models, there's binary classifiers, there's sequence to sequence, which one do I take and what do I do with it? What I always recommend is go to github.com, find a problem that's similar to the one that you're doing, and just copy their model, and use that as a template for iterating, because a lot of the research happening today is open source. It's a really active community that they publish their state-of-the-art results almost daily and in papers. And so it's really easy to find, I want to do image classification, state-of-the-art, search that on GitHub, and you'll find one that you can take and adapt with, and all you have to do, or your job then becomes put in your data points and make sure that it's producing outputs that you desire. Yeah, because it's an early field and it's moving so fast, a lot of those repositories get broken over time or broken by updates or outdated fast. So that's where understanding the fundamentals can help you get past those roadblocks. But definitely you'll save a lot of time if you kind of pick your models and your structure, your number of layers, the order of what you're doing based on what's already out there and what's working well for others. And then after you have that working, then you can go ahead and make yours better. The next step after having your model that you think will work for your use case is making sure that your data is clean and that it fits into that model. Because this is like talking about practical, putting the data into the code, whether it's taking a row in a CSV file and putting it, importing that into the model code, that's where you'll run into a lot of issues with seeing if your format's the same as their format. So yeah, doing a good job in the beginning with data storage will save you a lot of time here. This is a pretty common roadblock for a lot of startups. And then, so after you have that data split into a testing set and a training set, which you can take about 80%, 20% of the data based on what you're doing, then yeah, make sure, you want to take another look through to make sure that everything that's going into the model is as you intended it to be. One example is when you have duplicate lines in a spreadsheet, and yeah, you can use tools like Excel to figure out what the duplicate values are. And then if those two values are labeled differently, that can potentially confuse your model or produce unintended results. So being diligent about making sure that your data is what is perfect is important. And there's other tools that you can use, such as CSV-lint, files merge, to make working with the data easier. I think one area of improvement for the future that we'll see with deep learning is that all of this will be much easier to work with. Today it's literally spending painstaking hours in Excel and on your command line and trying to make sure that it's working the way that you want it to be, and then getting a bug and not understanding why it's there. But I think we'll see more visibility, and this is something that I think would be an awesome company to build, is more visibility into the actual underlying data that's informing the models. And that's not only from the company side, would that be important, but also from the user side. So imagine being able to go to Google search and having a very clear sense of what data they're using that is informing the predictions that they're making. So that today, that's possible. The next step is actually going and training your model. Once you've already picked it from GitHub, you think it works, you fit your data to it so that it's actually running. Now you can run it. There's different ways to run it on cloud GPUs if you don't have your own, which will improve the speed of runtime. Google Colab is free, which is awesome. It's like a free workspace that has a GPU that you can use. We personally use Paperspace, which is like a box in the cloud, and that looks like, yeah, basically it's just a cloud computer where you get access to a desktop and a command line, and it runs on a GPU, and they charge you per hour of use, I think. And after you get your model training, you want to make sure, one mistake that I see a lot of startups make is training models for too long with like not enough data, and you run into that problem of overfitting that you've seen. In practice, sometimes it might be hard for companies to realize that they're overfitting, but you want to keep an eye on when you're training your test data set accuracy is no longer improving, and usually you want to stop the process. Where today a lot of people assume by default that you just want to train it for as long as possible, and sometimes even training for an hour is too much if you have like a limited data set and a very simple model. So just keep an eye on that test set, because overfitting can lead to unintended performance when you deploy it. And then the next step with defining the model is, how do you know that the model parameters that you chose were the correct ones? And quick answer, you don't. What people do in practice is just continue trying and retrying, because this is an art. It's not a firm science yet. So people will literally just change parameters, rerun the model, retrain it, and see if the predictions are better. Definitely having a fundamental understanding of what's going on can inform your parameters decisions, but it still won't be the solution. So there's tools that help you do this actually. One is called SIGOPT, and what they do is they do Bayesian optimization on the parameter space, which means you give them all your parameters, they keep retrying different parameters, and then they pick the parameters that are leading towards better results for you automatically. So that can improve accuracy with little work. That's something that I would recommend. But yeah, there's lots of different parameters that vary, ranging from which layers you're using to how much dropout to how big is the sentence that you feed in, for example. And then finally, with model formulation, once you are satisfied with the predictions that are coming out, you're happy with the accuracy, you're happy with the data and the bias and it's not overfitting, then how do you actually take that to your users? So one way that I go about it is by hosting the model over an API, and you can use a service called Flask to do that, where you can, like this is what we do for production. We would call Fireflies.ai / check the sentence, and then that would give us a number from 0 to 1. And then given that we have all the importances, we can take the top 15 and give those to the user. And it turns out that works pretty well. There's other third-party services that simplify the process for you, so you don't have to host your own server. And there's, I think Facebook.ai just came out last week, and they're giving more of an end-to-end data pipeline. I haven't tried it out myself, but my impression of it is that you can put in your data, you can pick your model from the platform, and they'll host it for you. So that takes care of a lot of those steps that you have to do manually. I think, in general, this will keep getting easier and easier over time. And I would even say in like 5 years, this is going to be as easy as using Facebook. Maybe not that easy, but we'll see. And yeah, you can save your model through Keras or TensorFlow or Theanos, which are deep learning pipelines, which make it a lot easier to share and distribute. And then finally, after your model is integrated with your app or with your service that you're building, there's users on it, they're getting value out of it. That's not the end. How do you make sure that it's continuing to provide the right predictions that you expected? And how do you continue improving it with all of the changes that are happening in the industry? So measuring is the key here, and we keep a chart of how our model is performing. This is from a long time ago, but basically we measure false positives over time, false negatives over time, and what's even more important is tying that to your business or to the metrics that you're trying to drive. So for us, we want to make sure that people are looking at our notes consistently. That's a proxy for value for us. So so our model can tell us that it's 90% accurate, but what does that mean if people are not looking at it? So figuring out what are you testing against and are you optimizing for the right metrics is important. At the end of the day, this is a tool, and so tracking performance outside of the context of deep learning is important. And then, yeah, having Grafana is what we use to have that graph in this slide here. And that makes it easy. It's easy to set up if you have a good database structure. And then the other thing to think about is what happens when your predictions are wrong, because at the end of the day, this is just math, and it's a black box that it's hard to understand what it's going to do when you give it an input. So you should always plan for the case that your predictions are completely off. For us, that would look like Fred, Fireflies, thinking that so many irrelevant things are important and sending a long email with no value. There's other companies that, for example, X.AI is an AI assistant called Amy that schedules your meetings automatically. And you can CC Amy on an email, kind of like you CC Fred, and Amy will go back and forth and try to get a meeting time that works. But what happens if Amy gets the wrong time or sends the wrong email, schedules the wrong meeting? So for them, it's kind of catastrophic because you're ruining business days with your bad predictions. So their accuracy, their F1 score is a lot more important compared to a use case like Fred, where you get a bad note in your email, you can still continue with your day. So yeah, thinking about the negative use case, or what happens when you have a negative prediction, can help to inform how accurate you need to be. And yeah, again, I always want to stress automating as much as you can, because there are a lot of steps. So having a system that can alert you when the predictions are going wrong or when the metrics that you defined are inaccurate is going to help in the long run. And then finally, how do you continue to improve the model over time? For me, my favorite sources to continue watch for changes in the industry are 2-minute papers on YouTube. It's this guy who will read all the papers that are super technical, and then he'll make a video just explaining it in 2 minutes of what it means, and implications for the society. This is how I learn about most of this. I don't actually read enough papers. And then following the influencers that are making change in the space on Twitter is really helpful as well. And then, yeah, I would just say to keep learning. Like, that's my mindset as well. I'm always on the lookout for the next model to try, because I think it's super early on. I was at a talk where people were saying that deep learning today is similar to what the internet was like in 1996. So it's super complicated. There's a big learning curve. People can see the value, but it's unclear how that's going to affect society, and it's bound to have a lot of change in the next 10 years. So that's one thing to keep in mind when applying deep learning practically. And then finally, if you feel that you're doing well and you understand how your model is performing, definitely don't be afraid to experiment with adding in different layers or different parts from different research papers that you see, because yeah, if it actually improves your business results, then it's the right decision. So that's a lot of information that I got stirred you guys, and I hope some of it was useful. I can send the slides after as well. But what I wanted to kind of emphasize with this practical lecture was that it's really just a tool. It's not magic. It's kind of math. Whenever I see the words AI, machine learning on the internet, I wish I could just like Control F and replace them with math, because it's just statistics. And we want to use the technology, and we see it kind of like as electricity or a light bulb or a wheel, and we want to take that wheel and make a Tesla. and then we want to send it to space. So we see it like as something enabling for us, and that's I think how that's how I feel like more people should see it. And then finally, this is what we're doing again. So we're taking AI machine learning, and our goal is to, can you understand what's happening in all of these different types of calls, from sales calls to customer success calls to customer support calls. Like today, if someone complains about like a landing page, that information might go under the radar for weeks until it can get through the managers to the person who's actually responsible for that landing page. But we think that there's a better way by trying to understand what is actually important in these conversations. And so that's our version of a Tesla that we're trying to create with AI. And yeah, 10 minutes for questions.